Hello, and in this video I want to talk about Professor Templeton and the Armageddon Clock. Professor Templeton is a two-dimensional side-scrolling adventure game, or Metroidvania. With Professor Templeton, it's going to take place in a fictional English Victorian town of New Brighton. It features steampunk aesthetic and mechanics built off of that. So the first thing to know about Professor Templeton is his mechanical arm. This is going to function as the basis for the player to be able to remove level impediments and progress forward using gadgets that are transforming that mechanical arm into other useful purposes. The first I'm going to discuss is Magnet Grip. And Magnet Grip is a way for a player to move blocks that are impeding their progress in the level. With Magnet Grip, you'll have the ability to push a block out of the way. And I'm going to showcase that functionality now. So, we drop our player into the level, switch our gadget to Magnet Grip, stand within inside the box's collision range, activate Magnet Grip, and we're able to push. And that's Magnet Grip. So let's talk about how I built Magnet Grip. So Magnet Grip started with the block. And on this block, you'll see we have a box collision that extends outward from the block itself, and a physics constraint, which limits the motion of the block to the y-axis, the axis that we're using in our two-dimensional side-scroller. On the event graph, we have a begin and end overlap component event. And this is going to pass to our character to let us know that they can activate Magnet Grip. So on the overlap, when we begin with the magnet collision, we're going to cast the overlapping block to the character to let them know which block Magnet Grip is going to activate on. Then we're going to set is overlapped on the block so the block knows it's overlapped. Same for on end component. We're casting back to it. We're taking off is grabbing, which we'll see in the side-scroller character blueprint momentarily. Removing that overlapping magnet block from the side-scrolling character, letting the block know that it's no longer overlapped, and then beginning an event timer. That's based on check velocity. This is important for solving a bug that I'll talk about in a moment. So on our side-scroller character, this is the Magnet Grip blueprint. This is what it looks like when we activate Magnet Grip. So we're going to get that overlapping magnet block that we sent to the player. We're going to cast it back to the block BP and simulate physics on the block. Then we're going to change our current water to water power. This is what powers the mechanical arm. And then we're going to set is grabbing. And is grabbing is important because there's going to be actions we're not going to be able to do while we're in the grabbing state. So on the event graph, there are things we're not going to be able to do when in the grabbing state. So the first bug that I solved with the grabbing state is using other gadgets while in the grabbing state. So if we were grabbed in Magnet Grip, we could continually activate Magnet Grip. It didn't do anything except expend water, which is not a feature we wanted to include. Same thing for gadget swapping. We didn't want to have the player swap gadgets while activating Magnet Grip, because the animation for Magnet Grip when added will be the player attached to the block using that mechanical arm. We don't need it to be able to transform into another object without dropping the block. That'll be a bug that has to be worked out later. Now, velocity. Let's showcase why this is important first. So inside of our level here, we'll work through the level. Activate Magnet Grip. This block drops. Now, the player's never left the collision of this block. so it will not deactivate the simulate physics. However, on this block, if we activate magnet grip and push it off, we would leave that collision normally, and the block would stop simulating physics and float in midair. That's not optimal for the player's experience, because then the block can still get stuck in the player's way, impeding their progress and not allowing the player to activate magnet grip in a way in which they can then move the block. Now, because of the timer checking the velocity, once the block has stopped its motion, that's when simulate physics deactivates. So the player cannot go and push the block after it stopped moving, unless they reactivate magnet grip. And that is the importance of this event for check velocity. So we're going to check that component velocity, and as long as it's within 10 units of movement on the axis that are important here for velocity, as long as it's within 10 units, it will turn off the physics. So as long as it's not moving quickly at all, we're going to turn it off. This gives us a little bit of leeway in how we want it to work, so that if it's just slightly bouncing, it doesn't continually slightly bounce until there's no motion. It'll turn it off at that first indication that it's just a slight motion. Now, one of the bugs on working on magnet grip was on a pool. So with pool, that requires the use of a physics handle. I'm still working through how to properly utilize the physics handle for a pool. The issue when I implemented the physics handle is that once the component is grabbed with a physics handle, it stays grabbed until it's released. And so I could grab a component, like the magnet block, jump on top of it, and it would stay active and move with me. It doesn't do that here with the current use of magnet grip, but when using a physics handle it did. And that's a bug that I wanted to avoid, because that allowed the player to gain a tremendous amount of speed using the block to launch them in the direction that I didn't want, that was unintended. And so that's a bug that I'm working through. But the push functionality works really well with magnet grip. Thanks for stopping by and taking a look at the video. I appreciate it.